Hi, welcome to our new unit, Unit 3, dealing with transformations. So you're going to see a video dealing with what we're going to do for this unit. I'm just waiting for it to load.
Do the transformations in the GCSEs. You need to know the rules and you can do them with ease. There are only four of them, it's really a breeze. Proven unforgiven on a pair of axes. To find out how to do them if you listen to me. So the things you need to know are these. Reflection, move over in the mirror, rotation, spin around the center, translation, move up or down and sideways, large but get bigger or smaller. Plot the wanted image that you need to reflect. Measure from the mirror to the given object. The 3D rotation that you need to collect. The center of rotation is one thing you'd expect. The angle and direction give the desired effect. Use a tracing paper to check. Reflections, move over in the mirror, rotation, spin around the center, translation. Move up or down and sideways, large ones get bigger or smaller. Translation moves the object to the left or the right. You may go up and down to a different height. The last one is enlargement and to do it just right. The center of enlargement is the first thing to sight. You know it must go back to draw the image. It might be larger or smaller despite the word enlargement. Reflection, move over in the mirror, rotation, spin around the center, translation. Move up or down and sideways. Large ones get bigger or smaller.
Okay, so you've learned about the different types of transformation. So what you've learned was enlargement. Enlargement is also dilation. You've learned about rotation, reflection, and translation. So for each lesson, we're going to learn how to make that work on the graph. But for today's lesson, we're going to focus on reflection. And the objective is, how do we draw reflected images and identify lines of symmetry? So let's start with reflection, the definition. So the definition of that is a transformation representing a flip of a figure. So when you think of reflection, you think of looking at yourself in the mirror. That image of you is being flipped onto the other side in the mirror. So a reflection is an isometry. You want to know what isometry means? Isometry, you're going to hear that a lot, especially when it comes to transformation. It means that the image and the pre-image are congruent figures. So when someone says, oh, that's congruent, ding, isometry. So this is an isometry because they are the same. They are congruent. So that means the image is the result. The image is the result, the end product. And with the picture, actually I'll do that afterwards, the image can be reflected on a line or a point. But in this case, we're going to only reflect images over lines. So here we have an image. Got some figure that is being reflected over the line M. So in this image above, the line M is called the line of reflection. Simple as that. There's nothing fancy. It's a line of reflection, because basically you're taking this image and reflecting it to the other side. It's like it's a mirror. And that's the reflection for A, B, C, D, E, and its image is A prime, B prime, C prime, D prime, E prime. So anytime you reflect an image, the actual image over a line, and you label it, you're going to have those little marks, the one little tick mark, that represents prime. If you had two of them, then it would be called double prime. Alright, so there's going to be different types of reflection over on the coordinate plane. And remember, the coordinate plane is where the y and the x-axis meet and creates all the grids where you can have all the points on that graph. So if you're reflecting over the x-axis is the horizontal line. So that means whatever point you have, let's say your point was AB, it will become A negative B. And if you were to graph that, let's say you have this original image, you're reflecting over this red dotted line, which is the x-axis. See if I can make this bigger. The x-axis. Notice how A, your first point, A, stays the same, but your B becomes negative. It's the opposite. Same thing here. Same thing here. So you're reflecting over the x-axis. This x part, the first part, which represents like xy, this is your pivot. This stays the same, while the y is the one that's going to change. Now, if you're reflecting over the y-axis, which is the vertical line, AB, your point AB in that format, will become negative AB. So your B becomes that pivot, because your B is your y, and it will stays the same. And based on the picture, on the graph, this is your x-axis. So you notice how when you reflect over that line, this changes, it becomes the opposite, but the y in that coordinate point stays the same. Same thing here. And if you're reflecting over y equals x, it's basically that diagonal line, so your AB will be flipped, it will be BA. And to show that on the graph, this is your line, y equals x. So this is your original image. When you flip it, notice how your numbers switch. It stays the same, but they switch. So if you remember what happens over the x-axis, y-axis, and y equals x, then it will be easy for you to plot your points for the shape. Alright, so let's see if I make this bigger. Alright, so we have an example. So consider the quadrilateral KLMN with the vertices of, for K is 2, -4, L is -1, 3, M is -4, 2, N is -3, -4. It says draw the figure and reflect it over the x-axis. List the coordinates of the pre-image and image. Pre-image is the actual shape, image is your new shape. So, and we're reflecting it over the x-axis. That's why I highlighted. So now, do all of this. So this is a reflection of the y-axis. Let's see. Oh, good. All right, it fits. This is the reflection over the x-axis. I put all the pre-image points that they gave me, and notice how I put a little, I'm gonna call it a formula. It's not really a formula, but I'm trying to find a name. I'm drawing a blank. But for lack of a better word, I call it the formula for the reflection of the x-axis. So we use this, and then the image will give us this. So based on what I wrote, I have all my prime letters and then the new points for that image. Notice that the B is the one that gets changed. It will do the opposite, and the A will stay the same. So once I do that, once I get all my image points, then I plot it on the graph. So the pre-image, the actual image that they gave us, is in blue, and then the image based on the reflection of the x-axis, which I highlighted in green, will give me the purple shape. So that's how you would do it. For the next one, we have the same, actually let me make sure we have the same vertices that they gave us for the other problem, but now we're going to reflect it over the y-axis. So that means this x part is going to change. The a part is going to change, but the b is our pivot. So we write down what they gave us, and we're going to only change the a. It's going to be the opposite for our image. So once we get our points, and remember you have our prime, because if you label them the same, k and k, you won't be able to distinguish one from the other. So that's why we put prime. So now we have the pre-image that they gave us, and then we have the image based on our new points, based on the reflection of the y-axis. And you see the green line, the vertical line, that's our axis. So you see the image. So basically it's an actual reflection over the x-axis. Right, and same points, but now we're reflecting it over x equals y. So we have the pre-image. Notice that, remember, the numbers will stay the same, but you just switch the order. You're just switching it, and then we get our image. And based on our graph, that's our line, x, y equals x. We have the image, which is in blue, and then our new points for the image, based on the reflection of y equals x, and we have that purple one. So again, if you memorize what happens when you're reflecting over the x, the y, and y equals x, then it'll be easy for you to plot your points. Alright, so let's move on to some examples. It says square QRST with vertices Q, -1, 4, 2, 5, S is 3, 2, and T is 0, 1, and T 0, 1 in the x-axis. So we're going to do the reflection over that. So I'm going to plot the points first. We use purple, I guess. So that'll be 1, -1, 4 as my Q, and R is 2, 5, 1, 2, 3, 4, 5. My S is 3, 2, and my T is 0, 1. And I'm going to draw the lines for this. Draw lines, got it? Alright, so I got my shape. Now we're going to reflect over the x-axis. Let me see if I got, oh, there you go. So I had my points. And you know what? Since I had it in green, I'm to be crazy about this. I want to keep this in green. So turn this all green. What color green did I have? Oops, I didn't even do this one right. Sorry about that. I just want to make sure that everything coincides. Alright, green. So now that I know that I'm reflecting over the x-axis, I know that this A will stay the same, and then the B is the one that's going to change. So now I have my points based on the original and then the change. So I have my image, and I'm going to plot those points. So I got -1, and so I'm going to draw the line to show me that I'm going to reflect it over the x-axis. So that's my reflection. And then I'm going to plot the points. So we got -1, 4. That's going to be Q prime. And then 2, -5, 1, 2, 3, 4, 5. Oops, I made a mistake. That's supposed to be -4. I made a mistake. Gotta be careful with that. Ah, erase, erase, erase. And then go back to that. And then let's go back to that. So that was -1, -4. That was Q prime. 3, -2, which is S. And then 0, -1, which is T prime. And then I do my line. Connect them. And there you go. Notice how it's the exact same shape, but it's just reflecting over the x-axis. There you go. That's how you do it. If you know this, you need to memorize it. If you know it, then you'll be able to know how to plot based on what reflection they show you. All right, so we have a triangle, and they give us our points. And make sure I have select and not the wrong thing. So yeah. So use green, pen, 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 pen. All right, so we have our points. We got B, 5, 1, 2, 3, 4, 5, 0. That's not prime. B, and then we have C, -2, 4, 1, 2, 3, 4. And then we have -2, -1. So that's B, and then that's C. And I'm going to draw my triangle. Oops. How come I put, oh, oops. I'm so used to doing ABC that I didn't realize what I'm doing. Redo, and I'm just going to erase the letters. So used to ABC, and I realized I'm starting with B. So then now this is D, and then this is C. All right. And I want to change this so that way it corresponds with what we're working with. And now, since we're reflecting over x equals y equals x, so that's going to be our line. I'll use that, and I'll make sure that this is correct. All right. So now we're going to go to blue because we're going to do our image. So basically, because this is y equals x, the numbers are going to stay the same, but they're going to flip. They're going to switch their order. So now, based on that new image, I'm going to plot the points. So 0, 5, 1, 2, 3, 4, 5, which is going to give me B prime. Then I got 4, 1, 2, 3, 4, -2, which is C prime. And then I got -1, -2, which is D prime. And then I'm going to draw the lines connecting my points. And there we go. If you look at it, it's actually a reflection over that line y equals x. Okay, so that was the two different examples. So now, that line that we drew, it's called a line of symmetry. So the line drawn in a figure that creates a reflection from one side to another is called a line of symmetry. So if we go back to the picture, to the graphs, that pink dotted line represents the line of symmetry. So now we have example of different shapes, different items, and they ask you how many lines of symmetry can be drawn. So if you were to look at F, how many lines? Because we need to have one side has to be a reflection of the other. Is there a line of symmetry for F? No. So there's none. For this one, now let me take my line. I'll use this. So I know that this arrow here, arrow up here, I could split it this way. So I'm going to do the best as I can. And then I can also bring it down the middle. Because if I fold this, it will be the same left and right, and then up and down. So that means there are 2 lines of symmetry. How about this? Is there a line that we can create to fold this in half to make it symmetrical? Yeah, right down the middle, right here. So that means there's only 1 line of symmetry. And then for this sun shape, how many lines? Let's do this together. We got 1. We got 2. Most of you might say 2, but there's another one. 3. Another one. 4. So we got 4 lines of symmetry. Right. Some more examples. Determine how many lines of symmetry each figure has by looking at this. Let me go back to my line. We can split it this way. We can fold it this way. So there's 2 lines of symmetry. How about this? There's only, if you said 1, you are correct. 1 line. Let's go on to the next one. P. If you said none, you're correct. How about this one? I think some of you would say, oh, there's 1 line of symmetry. You might think you could cut it right through here. But if you were to fold it, would this point match up to this point? Would it look the same? No. There's no line of symmetry. How about the division symbol? Yep, we got horizontally, and we can do it vertically. I know it's off, but you get the gist. So there are 2 lines of symmetry. And then for the last one, the letter M. How many lines of symmetry do we have for M? If you said 1, you are correct, just 1. 1 line of symmetry. Oh, 2 more shapes. The plus symbol. How many lines of symmetry do we have? I think most of you might have said 2. Let's see, we have the horizontal and the vertical. But if you said 4, you are correct. We can also do it over here. And then have another line right over here. So there's 4 lines of symmetry. And what about Q? Nope, nothing for Q. Right. So let's recap. So we learned about reflection. That's one type of transformation that we're learning. And reflection is basically flipping a figure. And reflection is an isometry. That means it will produce a congruent image on the other side. And you can reflect it over a line, any object over a line or point, but we're just only dealing with lines. And when you have that image, make sure to put it prime, because you want to distinguish the lettering, the labels for the original pre-image to the image. And yeah, so yeah, I think I didn't mention that. The pre-image is your original and your image is the new. And there are 3 types of reflections. There's one is over the x-axis, where you have it turn into from AB to A negative B. Over the y-axis, which is the vertical line, AB becomes negative A, B, and over y equals x, which is the diagonal line, so AB becomes BA. And that line that you're reflecting over is called the line of symmetry. So it's just like the mirror. Think of your mirror as that line of symmetry. So you look at yourself, you see the reflection on the other side. Right, so if there was any difficulty with plotting and the reflection and stuff like that, remember you can always email me to get further clarification. And on that note, this ends our lesson, and Have a good day.